In the annals of history, few names shine with the same enduring brilliance as that of Euclid of Alexandria. In an era when knowledge was crafted on scrolls and passed down by word of mouth, Euclid emerged as a beacon of reason, an architect of logic who laid the foundations of a discipline that would define the way we understand space and form, geometry. Although the details of his personal life are lost to the sands of time, his monumental work, The Elements, stands as an imperishable testament to his genius and his impact. Let us imagine the bustle of ancient Alexandria, a vibrant and cosmopolitan city, a melting pot of cultures and the nerve center of knowledge in the 3rd century BC. There, in the legendary library, greatest repository of knowledge in the ancient world, Euclid not only studied, but also synthesized and organized all the accumulated geometric knowledge up to that point, from the earliest Egyptian and Babylonian works to the profound reflections of Greek thinkers such as Pythagoras and Plato. His goal was not merely to collect, but to establish an unbreakable logical systema chain of truths that would derive from one another with impeccable precision. The Elements was not just a simple book of formulas, it was a masterpiece of axiomatic deduction. Euclid began with a series of clear definitions such as a point is that which has no part, or a line is length without width, followed by 5 postulates or axioms, self-evident truths, and 5 common notions, logical principles applicable to all sciences. From this undeniable foundation, he proceeded to prove, step by step, hundreds of theorems, each one an irrefutable conclusion drawn from the preceding principles. This method, known as the axiomatic deductive method, was a revolution. For the first time, a science was built upon such a solid foundation that its truths could be verified and universally accepted. It is said that King Ptolemy I, impatient to learn geometry, asked Euclid if there was a shorter way to understand it than the arduous study of the elements. To which Euclid, with his characteristic wisdom, replied, "There is no royal road to geometry," a phrase that encapsulates the essence of learning and discipline. The influence of the Elements was immense and long-lasting. For more than 2 millennia, it was the main text for the study of geometry, logic, and deductive reasoning. It not only shaped the minds of mathematicians, but also those of philosophers, scientists, and even artists. Isaac Newton studied it meticulously. Abraham Lincoln used it to hone his argumentative skills, and entire generations learned to think with clarity and rigor thanks to Euclid's teachings. His system became the paradigm of science and rational thought. Although later non-Euclidean geometries emerged that showed his postulates were not the only possible truths, this did not diminish Euclid's legacy. On the contrary, it highlighted the depth of his thinking by establishing the framework against which future explorations of space would be measured. His work remains a beacon of logical coherence and intellectual beauty. Today, Euclidean geometry remains the foundation for countless practical applications, from architecture and engineering to computer graphics and robotics. The principles established by Euclid are fundamental. Every time we use a GPS, design a building, or play a video game, we are in some way applying the geometry that he so masterfully systematized. One of the most useful and frequently applied concepts derived from Euclidean principles is the calculation of areas and volumes, which is crucial in fields such as architecture, engineering, product design, and urban planning. From calculating areas and volumes to designing algorithms for 3D graphics, Euclid's vision continues to guide our understanding of space and provide the essential tools to build the world we live in. His legacy is not just a page in a history book, but a living force that drives innovation and understanding in the 21st century.